Hello, excuse me. Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 284. Please turn to page 284, and today is our lesson number 134. On page 284 you will find problem number 104, which says that if we have a quantity x in a box here, x in a box denotes the greatest integer less than or equal to x. That's what it denotes. The question is this quantity that appears in the box equal to 0? For example, what is the answer to this guy? Half. Here's our 0. Here is our half. What is the greatest integer that we can think of? X in the box denotes the greatest integer that is less than half. Listen carefully. The greatest integer that is less than half. Obviously, it cannot be equal to x. It cannot be equal to half because half is not an integer. So what is the greatest integer that we can think of that is less than half? The greatest integer that we can think of that is less than half is not 1, it is 0. The greatest integer that, one more time, the greatest integer, the highest integer, the biggest integer that is less than half is 0. So this equals 0. Similarly, 1/9, the greatest integer that we can think of that comes close to 1/9 is 0. Actually, I didn't mean to put 1/9. What I had intended to put was 9/10. 9/10 will be way up here. 9/10. Now you might think that since 9/10 is so close to 1, the answer should be 1. Answer cannot be 1 because it has to be the greatest integer either less than or equal to x. So if you were to say that 9/10 is 1, well then this quantity that we put here outside 1, it has to be either equal to 9/10 or less than 9/10. But 1 of course is more than 9/10. 1 is more than 9/10. It has to be either less than or equal to what you see in the box. What we see in the box is 9/10. So whatever integer that we put here has to be either less than that or equal to it. Obviously it cannot be equal to it because it's not an integer itself. Let's look at the first statement. Is the x in the box equal to 0? That's the question. In the first statement they tell us that 5x plus 1 equals 3 plus 2x. If you subtract 2x from both sides, 3x would equal, subtract 1 from both sides. I'm not going to do this baby thing, it's not necessary. Subtract 2x from both sides and you get 3x equal to, and subtract 1 from both sides equals to 2, and therefore x equals 2/3. Again, people in their haste might think, well, the closest integer that we find to 2/3 is 1. Yes, that is true. The closest integer that we can find to 2/3 is 1, but that is not what the question is asking. The question is asking us, what is the greatest integer that we can find that is either equal to or less than 2/3? Again, obviously it's not going to be equal to 2/3 because 2/3 is not an integer. So the greatest integer that we can find that is less than 2/3, the greatest integer that we can find that is less than 2/3 is 0. The answer to this thing is 0. They were asking us, is this quantity equal to 0? The answer is yes. Now the point here is not that the answer turned out to be affirmative. The point is we are able to say either yes or a no. Even if it were no, the first statement by itself would have been sufficient because we just have to be able to say yes or a no. Here the answer actually just turns out to be yes. Yes, it is affirmative. Yes, it is equal to 0. The first statement by itself enables us to answer the question either in a yes or a no. Since the first statement by itself is enough, AD, BCE. AD, BCE. Since the first statement by itself is enough, the answer cannot be B, C, or E. It would have to be either A or a D. Let's look at second statement. In the second statement, they tell us that that x lies somewhere between 0 and 1. That's how I want you to read it. That's how I want you to read it. Don't go around reading it 0 is less than x, which is less than 1. It doesn't tell you anything. You have to read it in a manner that gives you some intuition behind it, that gives you some feeling behind it. Read it in plain English language. Don't read it as a nerd in a mathematical way. X is somewhere between 0 and 1. So let's find out. Let's contemplate a couple of values and see what happens. So right here, we just did it. X is somewhere between 0 and 1. It doesn't matter what x is. If x happens to be half, we already discussed it. If x happens to be half, then the greatest integer that is less than half, is 0. Question was, is this quantity equal to 0? Is this quantity equal to 0? The answer here is yes. If it happens to be 9/10, the greatest quantity, the greatest integer that is less than 9/10. One more time. The greatest integer that is less than 9/10 is 0. Even if it happens to be 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. What is this? I don't know what that number is. You see? 9,999,999 divided by 10 million, that is damn close to being 1. But still, the answer is not 1. The answer is 0. Because it has to be either less than or equal to. It cannot be greater than. The answer cannot be greater than, whatever answer here is, that answer cannot be greater than this quantity. That answer has to be either less than this guy or equal to this guy. Obviously, it's not. We cannot put here anything. We cannot put. There exists no integer that is equal to this guy because this guy itself is not an integer. So the greatest integer that is less than 9,999,999 divided by 10 million is 0. So the second statement by itself also is enough. Second statement by itself also enables us to answer the question, is this quantity equal to 0? The answer is yes. The answer is D. Let's see what they give us in 105. You want to do one more? Yes? Let's do 105. Next one. $105 is a straightforward algebra problem. It says A costs $3 per kilo. We are told that B costs $5 per kilo. We are told that a 10 kilogram mixture consists of X kilogram of A and Y kilogram of B. Again, one more time, we have a mixture which weighs 10 kilogram. It contains some of A and some of B. We are told that A costs $3 per kilo, and we are told that B costs $5 per kilo. Question simply is the weight of A greater than the weight of Y? Do you understand? Now, just less than a second ago, I looked down to see if it says greater than or less than. In reality, it doesn't matter what the question is. Even if the questions were like this, we would have done the exact same work. Because if the question was, is x less than y, in this scenario if the answer happens to be negative, then in the other scenario the answer would have to be affirmative. And since we really don't care whether the answer turns out to be yes or a no, we just have to be able to answer it either in affirmative or negative manner. What it is, we really don't care. So as long as we can answer yes or a no, that's all we need. Let's see what they tell us in the first statement. In the first statement they tell us that y is more than 4. I think I took up too much room. Y is more than 4. Now if y is more than 4 kilogram, and since the total is 10 kilo, and if y is more than 4, that would imply that x would have to be less than 6. Obviously, because they have to add up to 10. So if y is more than 4 kilos, the x would have to be less than 6 kilos. Because altogether they're 10 kilos. Now does that tell us if x is more than y? All we know is that x is less than 6 and y is more than 4. Does that tell us if x is more than y? The answer is no. For example, for all we know, y might be 5 and x might be 5. They might both be equal. If y is 5, in which case we satisfy this condition, y is more than 4. If x is 5, we satisfy this condition, x is less than 6. So that's a possibility. That's one scenario. Or maybe x is equal to, maybe y is equal to 9 and x is equal to 1. If that happens to be the case, again we satisfy the condition, y is more than 4. We satisfy this condition, x is less than 6. So that is also possible. This is possible. Or maybe it's something weird like this. Maybe y is 4.5 and x is 5.5. Again we satisfy, fulfill the condition, y is more than 4 and x is less than 6. We really can't tell, just by knowing that y is more than 4 and x is less than 6, we really can't tell if one is bigger than the other. They might both be the same size, same amount, that is 5 kilos each, or one might be less than the other. One might be less than the other. Here y is bigger, here x is bigger. Here they're equal. I've shown you 3 different scenarios, it could go anywhere. It could go any of these ways. So first statement by itself does not enable us to answer the question, is x more than y? To which answer would be, how the hell do we know? Since we cannot answer the question, A, D, B, C, E. Since we are unable to answer the question, since the information in the first statement is not sufficient, answer cannot be A or D. It would have to be either B, C, or E. Let's see what they give us in the second statement. I'm going to erase all this thing. I need a little bit room. I'm getting too low here. In the second statement they tell us, cost of 10 kilo mixture is less than $40. Since A costs $3 per kilo, that would imply that x kilo only has one S, I believe. X kilo will cost 3 times x dollars. Because each kilo costs $3. If you were to buy x kilos, it will be 3 times x. Similarly, since B costs $5 per kilo, that implies that since the total is 10 kilos, if total is 10 kilos and A is x kilos, if A is x kilos, that implies that B must be whatever is left, 10 minus x kilos. 10 minus x kilos. Therefore, since B costs $5 per kilo, 10 minus 5 kilos must cost 5 times that amount, 10 minus x kilos. 10 minus x dollars rather. That's it, we're almost done. We add up the two amounts, the 3x dollars and 5 times 10 minus x dollars, and that has to be less than 40. Therefore, this amount, the cost of the material A, which is $3x, plus the cost of the material Y, which is 5 times 10 minus x, has to be less than 40. Has to be less than 40. Let's open it up. Let's solve for x. 3x plus 5 times 10 is 50. 5 times x is 5x with a minus sign here, so minus 5x is less than 40. 3x minus 5x is negative 2x. Is less than 40. Bring the 50 on, this 50 on this side, and we get 2x is less than negative 10. If you want to multiply both sides by negative 1, if you were to multiply both sides by negative 1, it will change the directions. It will change the direction of the inequality. Very quickly here, for example, we know 3 is less than 4, but if you were to multiply both sides by negative 1, then negative 3 is no longer less than negative 4. Negative 3 is more than negative 4. It changes, it switches the directions of the inequality. If you were to multiply an inequality by a negative number, or if you were to divide an inequality by a negative number. If you multiply or divide an inequality by a negative number, it switches the direction. So that's what it is here. So now negative times negative is positive, so 2x is greater than 10, which tells us that x is greater than 5. What was the question? Since x is greater than 5, since x is greater than 5, we just found, that implies that y has to be less than 5. Why? Because they have to add up to 10. They have to add up to 10. The question was, is x more than y? The answer is yes, it is. We just found it. X is more than 5 and y is less than 5. So yes, x is more than 5. The second statement does the job. The first statement did not. Therefore the answer is B. The answer is B. I'll see you tomorrow, okay? Why does my notes here say D? It should say B, because we found that the first statement was not enough. Let me just quickly, I'm getting paranoid here, let me check the answers. This was question number 105. 105 is B. I do not know why I have written D in my notes. The answer is B as in boy. Right there. Second statement by itself is enough. First statement was no good. I'll see you tomorrow, okay? Bye now.